and wideband system. In narrowband system, relate the bandwidth of signal. We know the bandwidth is this, the component of message signal, to the expected coherence bandwidth of the radio propagation channel. We have our signal bandwidth, and we are passing through the channel, and we know this channel also has some bandwidth. Okay. Then the channels are usually operated using FDD. The channels are usually operated using FDD. Wideband system. The transmission bandwidth of signal channel. The transmission bandwidth of signal channel is much larger than the coherence bandwidth of radio channel. In wideband system, we have wideband system means our signal bandwidth is much larger than the coherence bandwidth of the radio channel, and multipath fading does not greatly affect the received signal within the wideband channel. Narrowband systems and wideband. Frequency selective fades occur only in a small fraction of signal bandwidth. Frequency division duplexing and time division duplexing. Duplex means what? Here we have 1 0 and we have number of channels. Yes. FDD provides two simplex channels at the same time. One channel for incoming and for outgoing. At the same time, TDD provides two simplex time slots on the same frequency. The frequency will be same and we have different time slots. Yes, different time slots. The frequency will be same. The next one is frequency division multiple SS, where we have same channel and multiple users are accessing the same channel. We can use this single channel for multiple person, and how we can achieve this is outlined here. Usually implemented in narrowband system. Narrowband system means our signal bandwidth is less. Bandwidth of signal expected coherence region. The available radio spectrum is divided into large number of narrowband channels. If an FDA channel is not in use, then it sits idle. Yes. Suppose this is one path and this is another path. If the vehicle is not coming, it is idle. No one will use this. Yes. And it is essentially a wasted resource. After the assignment of voice channel, the base station and mobile is transmit simultaneously and continuously. The bandwidth of FDMA channel are relatively narrow, only 30 kHz. Yes, as each channel supports only one circuit per carrier. That is, FDMA is usually implemented in narrowband systems. The symbol time is large as compared to average delay spread. This implies that amount of interference intersymbol ISI is low, because ISI means the data bit rate. Yes, we have 1001 like this, they are not scrambled. Thus little no equation is required in FDMA narrowband systems. The complexity of FDMA mobile system is lower when compared to TDMA systems, because every user gets one fixed carrier frequency. Though this is changing as digital signal processing methods improve for TDMA. Since FDMA is continuous transmission scheme, fewer bits are needed for overhead purposes, such as synchronization and framing bits, as compared to TDMA. It is relatively easier multiple access system. FDMA mobile units uses duplexers since both transmitters and receiver operate at the same time. It uses duplexers. In this result in an increase in the cost of FDMA subscriber unit and based stations. FDMA requires tight RF filtering because the user, this one is using this F1 frequency and another is using this F1 F2 frequency, and this is the common frequency ranges. The frequency spectrum is common for this, and so we need guard band. Non-linear effects in FDMA. Many channels share the same antenna at the BS. Yes, all users. This BS means this tower. Yes. When operated near saturation for maximum power efficiency, the power amplifiers are non-linear. They show this property, not this. They show this type of property, exponential. Can cause signal spreading and generate intermodulation frequencies and adjacent channel interference. Number of channels supported in FDMA. N is the number of channels. Yes, how many channels? If we have total bandwidth of this, total bandwidth is provided by government is BT, and we require guard band for separation of channels, and this is BC is the, for one user they will get this much bandwidth. This is total bandwidth, and we require guard band and divided by the bandwidth for channel. Here BT is total spectrum, guard band allocated at the edge of the spectrum. If this is one user, then this, suppose this is guard band, and here one user or two user. Yes, like this. Same thing, channel 1, channel 2, channel 3, total frequency available, this is bandwidth, time is same for all, and code is same for all. Frequency division multiple access. Total BT is 12 our total whole spectrum is 12.5 megahertz, and guard is 10 kilohertz. One side here also we need guard band, and this side only the user can use this much spectrum. Yes, and BC is 30 kilohertz. This is 30 kilohertz. And find the number of channels is 2.1.25 10 to the power 6 minus 2 times guard band is 10 kilohertz, 10 into 10 to the power 3 by BC is 30 kilohertz. This is the answer. So 416 can be the channels available for this total bandwidth. The bandwidth is 12.5 megahertz, and we can one at a time 416 people can talk to each other. TDMA shares a single carrier frequency with several users, where each users make use of non-overlapping time slots. Yes, time slot will be different. Number of time slots per frame depends on several factors such as modulation technique, available bandwidth, etc. Number of time slot will be dependent on modulation techniques and available bandwidth. Data transmission for users of TDMA is not continuous. Yes, discontinuous. Suppose I get this channel and another person get this channel and another person get, so not continuous, but occurs in burst. This results in low battery consumption, and since the subscriber transmitter can be turned off when not in used. Because of discontinuous transmission in TDMA, the handoff process is much simpler for a subscriber unit. Yes, handoff is very easier since it is able to listen for others base station during idle time slots. An enhanced link control such as that provided by mobile assisted handoff MASO can be carried out by a subscriber by listening on an idle slot in TDMA frame. TDMA uses different time slot for transmission and reception. yes, reception different slots. Thus duplexers are not required. In FDMA duplexer is required. Even if FDD is used, a switch rather than a duplexer inside the subscriber is all that is required to switch between transmitter and receiver during TDMA. Adaptive equalization is equally necessary in TDMA systems since the channel in transmission rates are generally very high as compared to FDMA. In TDMA, the guard bands should be minimized. No need of guard bands. No need. If the transmitted signal at the edge of time slots are suppressed sharply in order to shorten the guard bands, the transmitted spectrum will expand and cause interference to adjacent channel. Yes. If the transmitted signal at the edge of time slots are suppressed means their gain is low, yes, the filter, then it will cause interference to adjacent channel. Then high synchronization override required in TDMA system. High synchronization override is required in TDMA system because of cross transmission are slotted, and this requires receiver to be synchronized for each data. In addition, GOG slots are necessary to separate users, and thus the results TDMA systems have larger overheads as compared to FDMA. In FDMA, exclusively the user can use, but in TDMA, the exclusively user cannot use. TDMA has an advantage that is that it is possible to allocate different numbers of users per frame for two different users. Different number of time slot per frame to different users. Thus, bandwidth can be supplied on demand to different users by concatenating or reasoning time slot based on priority. Here, the formula to calculate the number of channel slots in TDMA is the bandwidth total to guard band BC. This is one is here. This is for FDMA, yes, and here we multiply this by M, where M is the number of time slot on each channel. Yes, if only one time slot, then it is equal to 1. If it is 2, then it will be increased number of channels. Yes, number of time slots. If number of time slot is 1, then TDMA and FDMA are equal to. If M, which is number of time slot, is increased, for example 10 times, then for that system it is 10 times increased. Yes, here time slot are given. See, the frequency is same and there are more channels according to time slots. We said that there is required of overhead for synchronization purposes. So the preamble, message information and trail bits are required in one TDMA frame. The message is slot 1, slot 2, slot 3 and slot n. This is which you have, this one is, yes, and each slot has trail bits, sync bits, information data and guard bits. Yes, this is one frame. The preamble contains address and synchronization information that both base station and subscriber use to identify each other. Guard times are utilized to allow synchronization of receivers between different slots and frames. GSM, yes, in GSM TDMA is used, yes, that is 25 megahertz for forward link. Suppose this is 25 megahertz, which is broken into radio channels of 200 kilohertz. Yes, 200 kilohertz channel. If 8 speech channels are supported on a single radio channel, and if no guard bands is assumed, find the number of simultaneous users that can be accommodated in the GSM. Solution is the number of simultaneous users that can be accommodated in GSM is given by 25 total by, we have, this is the total bandwidth for one channel. Yes, and each channel, suppose this is from here we get 10 to the power 6, 10 to the power 3. Yes, this is 200, means this is 8, 10 power 6 by 8, 10 power 3, for example. And here we all know that if 8 speed channels are supported on a single relay channel, and this one is of 200 kilohertz, here it is said that for forward linkage, and this can support 8 users. So this is 8 divided, so there it can accommodate, this is divided, so it is can accommodate 1,000 simultaneous users. And the thing is, GSM uses a frame structure where each frame consists of 8 time slots. Suppose 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, yes, and each time slot contains 156.2 bits, and data is transmitted at 270 years old, and data is transmitted at 270.833 kilobits per second in the channel. Find the time duration of a bit. Time duration of a bit means the data is transmitted at a rate this. Data rate is 270.833 kilobits. Yes, in 1 second 270.833 10 to the power 3 bit are transmitted, and in 1 bit it will take time 1 by 270.833 into 10 to the power 3. The answer is this for 1 bit. Yeah? And then the time duration of a slot. Each slot has time duration. Each time slot duration. Yes, each time slot duration. The time slot duration is, each time slot contains this much bits. 1 bit requires this much time, and if and that each time slot contains this much bits, then it is just multiplied this by this. It will say 0.577 milliseconds is coming. And frame edge, each frame edge 8 slots. So time duration, and how long must a user occupying a single time slot must wait between two simultaneous transmission is this much. The time slot duration is this frame, one complete one frame, and next frame is this. So if the user is here, between here, and he will get in another frame here, so it will take one slot duration. This is 4.615 millisecond. You do this one, but let's do normal GSM time slot consists of 6 trailing bits. Yes, 6 trailing bits, 8.25 guard bands. This is time slot. 6 trailing bits, suppose this is 6, and 26 trailing bits. This is, suppose this is 26 training bits, 2 traffic burst of 58 bits of data, 2 traffic burst of 58 plus 58. Okay, find the frame efficiency. Time slot has 6, these 6 trailing bits. 8.25, where is 8.25? The guard band, yes, 8.25. Suppose this is 8.25. Then 26 is trailing bits and 2 58. 58 plus 58, this is data. Total bit is this much. And a frame has, we know, a frame has time slot 8 time slots, yes, TS. So 8 into this, total bits will be this much per frame. And number of overhead is, this one is overhead, this is overhead, and this is overhead, yes. And total overhead are 8 times 6 plus 8 times 8.25 plus 8 times 26. 322 bits are overhead. Efficiency is 1 minus this by this, so 74.24% data are supplied, and the efficiency is this much. Now this much.